Okay, so when we do these types of problems, we're going to have a few variables that are pretty standard. So X is typically the number of units sold or produced. Then we have this function P of X, which is the price per unit if X units are sold, right? So if you sold 10 units, P of 10 is the price that you sold each of them at. We assume that each unit was sold at the same price. This is also called the demand function. You may have heard that term in your economics classes. We won't really do much with the supply function, so it's not really a thing. Then we have the R of X, that's just the revenue, total revenue from selling the first X units. So if you sell 100 units, R of 100 is the amount of revenue that you've made. Right. And in general, we also have the fact that revenue is what? Revenue in a nice English description is the number of units you sold times the price. And these are just a basic definition, right? Right. If you sold 100 units each at $2, you just made $200, right? So that, in other words, revenue is also X times P of X. And then we have, costs. So C of X is the total cost of, again, the first X units. And C of 0 is typically not 0. So C of 0 is usually non-zero because there's usually a cost to at least just starting up everything. So that's usually called the sunk cost. So again, these are terms that you probably have heard, or you should have heard in an introductory, say, microeconomics course. Okay, so the thing that we actually want to concentrate on are these things called marginal quantities. So have a lot of you taken intro microeconomics or intro economics? I say like half and half. So have you talked about marginal currently taking? Have you talked about marginal quantities, marginal cost, marginal revenue? So that means I should be able to ask you guys, what is marginal, say, cost? And you should be able to tell me what marginal cost is. The real definition of marginal cost. And now I see everyone going, no, I'm not actually taking microeconomics. I was kidding. Extra cost. It's something to do with extra costs, but obviously we have to be more precise about that. Does anyone happen to know the precise definition? Isn't it an additional cost per unit of good? Okay, I think that's probably the closest we're gonna get. So it's the additional cost we get by producing one more unit, right? So in general, when you talk about the marginal anything, marginal revenue, marginal cost, marginal whatever. So let's say MQ. So Q in this case can be revenue or cost. So MQ of X, the definition is, let me see what I want to write down. It's the additional amount of Q again, whatever Q happens to be, it's usually cost or revenue. So the additional amount of Q achieved if one more unit is produced or sold. There's this caveat, assuming X units are currently being produced. So in other words, I've already made 100 units. I want to know what happens if I produce one more unit. If I go to 101, I'm already at 100. What happens if I go one more? The marginal cost would be the additional cost I incur by going from 100 to 101 units. Now we can already see how linear approximation is going to fit into this, right? I introduced this in this chapter, this section, for a good reason, right? Marginal cost is fundamentally concerned with a difference, right? It's concerned with the additional amount, right? Just that little bit, the difference between the cost of 101 units and the cost of 100 units, right? And we just saw an example, that concentration example, where linear approximation can be used to approximate differences. So that's what's going to happen here. So there actually is a standard approximation that we use in economics for marginal quantities. So let's see. And before I write that, I did miss just one thing. So according to this, what would be the actual formula for mq of x? Well, it would be what? It would be q of x plus 1 minus q of x. So I just said that. Again, think about the cost. I have 100 units and I want to produce 101 units. What is my marginal cost? It's the cost of all 101 units minus the cost of the 100 units, right? I need to subtract off the cost I have already incurred. So this is just the additional, that little bit of extra cost, right? The difference. And again, we've seen how differences can be approximated using linear approximation. And how is that going to work? Well, x and x plus 1 are near each other. So let's see. Tangent line, sorry, to q of x at x equals a is what? It's q of a plus q prime of a times x minus a. Note, if x is near a, then what does this mean? We've been talking about this whole time. Then that means the original function q of x is approximately equal to q of a plus q prime of a times x minus a. So this is nothing new. What I just wrote down is the tangent line formula, and I'm just repeating our main fundamental principle for today's lecture, that the tangent line approximates the original function near the point of tangency, right? If x is near a, these two things are approximately equal. Now here comes the cleverness. Well, notice that at the top of the screen, I want to figure out the difference between q of x plus 1 and q of x. So this is what I'm going to say. Since a plus 1 is near a, right? If x is near a, well, is a plus 1 near a? Probably, hopefully. I mean, the context of these problems is usually that a is a pretty big number, or maybe like 10 or so. I mean, you have to assume that a plus 1 and a are kind of close to each other. Since a plus 1 is near a, we get that q of a plus 1. So everywhere I see an x, I'm putting a plus 1. And here I would just get what? A plus 1 minus a. That cancels out. I just get 1. And rearranging gives us what? If I just if I move the a plus 1, so if I move the q of a over to the left side, I get this. Awesome. Why is that good? Because this was exactly the marginal cost, or the marginal q at a. So you may have heard your macroeconomics teacher, I don't know. If it's based on derivatives, it probably isn't if you can take it concurrently with this class. But you may have heard somewhere that the marginal cost is the derivative of cost, right? So I just proved to you that, so marginal cost is not the derivative of cost. Marginal cost means the additional cost you get from one more unit. I mean, that's what it is. The marginal cost is that it would be c of x plus 1 minus c of x. It's that function. It's this difference function. However, I have just shown you that I can use a tangent line approximation to approximate the marginal cost using the derivative of cost, right? This this thing says MQ is approximately equal to Q prime. So if you want to know how much that additional unit is going to cost you, calculate the derivative of cost at wherever you are right now. So if I want to know what is the cost of 101 units minus the cost of 100 units, right? What is the cost of that one extra unit if I'm already doing 100? That is approximately equal to the derivative of cost at 100. That is what this approximation says. Okay. Can you scroll up a little real quick? There you go. I'll just zoom out. So that's what we have right now. And so we're going to summarize this anyway. So let's summarize. So I do need to zoom in now. Marginal cost. I have C of x plus 1 minus C of x, and then I have C prime of x, right? And the same thing goes for marginal revenue. I'm going to add a little note to these in just a second. Right, this is the exact formula, and then that is our approximation, right? So marginal cost, the definition is C of x plus 1 minus C of x, but I can approximate it using C prime of x. And the same thing goes for revenue. Please make sure that you understand that you evaluate the derivative at x. In other words, the smaller, where you are right now is where you evaluate the derivative, not where you're going to be. Not at x plus 1.